All right, welcome to the Unit 4 review. A couple of things to take note of. First is that this video, I'm going to talk a little bit about the unit as a whole, how it relates to what we've done so far, and then I'm going to give you some questions that you can use as a practice test, if you will. So here's what you should be completing before going into those questions. You should be updating your definitions and examples packet. You should be reworking problems from homework and that we've done in class, making sure that you feel really confident about every topic that we've covered. And that means not only can you solve questions involving those concepts, but that you truly and deeply understand why those certain concepts work. Why does the first derivative, second derivative test work? Why does the second derivative determine concavity? Just as a couple of examples. Then and only then should you complete the review problems that are here. So that being said, let's go ahead and talk briefly about this unit as a whole. Alright, so just a brief overview. We started off obviously with the need for a limit, constructed the idea of what a limit is and used it to give meaning to functions that were undefined at a given point. We extended this idea to helping us define what the derivative is, or the instantaneous rate of change of a function, and used the limit to find those. Then we realized that using the limit definition every time we're given a function is a little bit repetitive. We're seeing that we're doing the same things over and over again. So we use the limit definition to figure out some rules for general functions in general, and constructed rules for finding the derivatives of many different types of functions. So now that we can find the derivative and the second derivative of a function with ease, now we're going to start with the application. So what can the second derivative tell us? And that's, of course, what we spent our time with in Unit 4. So here's sort of a list of topics that we've covered. Where is a function increasing or decreasing? And of course here, when we're trying to determine intervals where something is increasing or decreasing, we're making a sign chart of our first derivative. Then of course we have the mean value theorem. This is an incredibly important theorem, and it's really necessary that you understand what it's saying and then what it allows you to do. So you're on a closed interval from a to b, and you have a continuous function that's differentiable. You can then say, okay, well, what's the average rate of change on that interval? And that at some point in between a and b, there has to be a place where the instantaneous rate of change is equal to that average rate of change. In other words, and that's a great video to go back and watch, just to make sure that you understand the conceptual and understanding behind it, and that you have a good visual of why the mean value theorem works. Next, we did discuss extrema for a little bit and talked about the first derivative test. And of course, the first derivative test, you only need the first derivative, but I want to discuss concavity and points of inflection first, because then we can discuss extrema with both derivative tests. So the concavity of a function is determined by the second derivative. Of course, the second derivative is the rate of change of the first derivative, so it's telling you how the slope is changing, whether it's increasing or decreasing. And of course, a point of inflection is where the concavity is switching from concave up to concave down, or in other words, where the slope of the original function is constant. So that's an important thing to think about. So determining concavity or points of inflection, we're going to want to make a sign chart for the second derivative. Then thinking about the extrema of a function, both the relative and the absolute extrema, we have two tests that will allow us to determine extrema, the first derivative test and the second derivative test. So the first derivative test, of course, is where we're using the first derivative, making a sign chart of the first derivative, and looking for points where the first derivative is changing sign, because at those points we'll have a relative extrema. And we can also use that. The test also tells us how to evaluate endpoints of a function, so that's also incredibly important. The first derivative test is incredibly useful, very simple. Also have the second derivative test, and the second derivative test allows us to determine relative extrema by looking at first where there is a point along our function that has a horizontal asymptote, where the first derivative is equal to 0, and then we use that point, wherever that is, plug it into our second derivative to see whether we have a concave up or concave down, and that way we can determine whether it's a relative min or a relative max. So make sure you're very familiar with those tests. Obviously need to have them memorized and be very familiar with utilizing them. Next, we use the first and second derivative to construct our original function, either by creating a graph of it or just being able to answer certain questions about our original function. And here it was incredibly important to make sign charts for the first and second derivative, and to write down what each interval, what's happening on each interval. So, is the function increasing? Is the concave up? Is the function, decreasing, concave up, so on and so forth. So 2 sign charts will allow us to construct our original function. And then finally, we took kind of all of these ideas here and applied them to some real-world situations. So we talked extensively about motion, but also about some other situations involving a function that we can then take the derivative or second derivative of and use what we can learn from those first and second derivatives to make sense of that particular real-world situation. So make sure that you are familiar, obviously, with all of these concepts, that you answered successfully a bunch of questions about them. And then once you've done so and you feel really comfortable with them, go ahead and move on to the problems that I'm going to put up here in a second. Alright, so here are the problems. Notice there's about 20 or so of them, which obviously is a little longer than an actual test will be, but if you can complete these successfully, then you will be in great shape for the assessment. A couple of things to point out: there are a few of questions that will take a minute, a few that will take 10 minutes. So not all of these are going to take an extensive amount of time. There are some really good multiple choice questions that you want to make sure you understand why the correct answer is the correct answer. So go through, treat these questions as if they're test questions, and then go through and either look at the answers in the back of the book or use the solutions video that will be up soon to determine where you might want to go back and review some concepts.